Hi everyone, really good to see you. Matthew Kennedy here. Hope you had a great spring break. We're going to be talking about our Module 7 discussion board 1 post, which answers these two questions. Both Newton and Leibniz had their own reasons for creating the calculus. What were they and why? And then also we have the developers of methods were called into question by philosophers of their time. On what basis were their objections? So the thing I'll say about Newton and Leibniz first in talking about calculus and really the reasons why each of them went about it. Personally, for me, if I were to sit each of them down, I would say Newton sought to go about mathematics in a way to advance science, whereas Leibniz went about calculus for just pure calculus and mathematics. I'm not really saying that Newton did not do mathematics, but what I'm saying is that he jointly went about science and math at the same time. We have Newton's laws. We have his whole thing with Robert Hooke in the James University video about optics and gravity, and obviously his white light discovery in 1672. But you really think about, like, this says it all. Newton in 1669, fluxions, and how he said the rate of change, when if I have a particle and its motion, its velocity at one given time is essentially it's like it's the graph of the derivative, right? We literally have a particle's motion that is going to be just, your normal function in terms of math. If I graph its velocity, that's the derivative function. Acceleration, that is the derivative of the derivative, f double prime. And you really think about how that applies to science. Someone's motion, a particle's motion, it's very science-based. And Newton has gravity again. He did so much work in advancing the scientific world, but calculus being the study of how things change, it really plays a huge role in the science world. So Newton was a very, very, very scientific person. Whereas Leibniz, it's not that he wasn't scientific, it was just more of, from what I read and what I was taught in this module, he was more of a straightforward just mathematician. There was nothing that I got vibes of he helped the science, he didn't do much for science that he did for math, whereas Newton did both math and science. So Leibniz, and by the way, I want to first of all talk about these people here. This was in the James University video. These were some contributors that were laying the framework for Newton and Leibniz. Viete, who really ended the algebraic era of mathematics with algebraic notation application. We had Descartes, who did analytical geometry and Cartesian coordinates. Cartesian coordinates were huge in calculus too, right? Theta and a radius. The first talks of a infinitesimal value was Cavallari. I can't even say it. Infinitesimal values are huge in calculus. So Cavallari, where's his credit? I think he deserves it. We then have Barrow, which kind of brought up tangent lines and also the first talks of the fundamental theorem of calculus, FTC. Fermat was the power rule for rational values of n. So you really think about what those individuals did. That was before Leibniz and Newton had any publications, even before Newton of 1669 about fluxions, which was the particle of velocity. So you think about those individuals, and you think about, again, I already talked about, what Newton did to go about calculus. Leibniz was more mathematical. But now we really get into the question here, and this is pretty much the premise of the video, the deep part of it. What were these objections and what basis from these philosophers? It was about Leibniz possibly plagiarizing off of Newton. And you really go about what Leibniz did. Leibniz, first of all, in his mathematical career, and really his scholarly career, he exchanged many letters with Collins, Oldenburg, and Newton. And it also says in Hodgkin, chapter 7, it states, "The question of plagiarism is more unpleasant and complex, since Newton's version was not published in his lifetime, but was seen in manuscript by a number of people. Leibniz in the early 1670s, which was after the Fluxions were published in 1669, knew of some of Newton's work, chiefly by accounts and letters from London, and most famously by two devious and obscure letters from Newton himself, which contain references to his most important work in the form of anagrams. So, in going off of that reading, I was able to read about how, and you might say, oh, the reading said that Leibniz, that he plagiarized for sure. You think that. But then later, in a different part, page 166 of Hodgkin chapter 7, it says, modern scholars, see particularly Hall of 1980, are agreed that Newton's communication was both too late and too obscure to exercise any serious influence on what was effectively an independent discovery by Leibniz, with his own ideas and notation. He too delayed publication, and was only forced into a brief announcement of his results in 1684 by fears that he in turn was losing priority. So the one thing I'll say is that it's like, I feel like it goes both ways. You hear some things that are in favor of Leibniz being a plagiarizer, some things that aren't in favor of him being a plagiarizer. And you go about what Leibniz did. He, in 1684, he did the power rule for irrational values, whereas Fermat, he did rational values of n for the power rule. He talked about the dy dx notation for the first time, the product rule and the quotient rule. 1686, he published a work about the integral notation and integrals in general, right? That squiggly line. In 1693, he really advanced he advanced Barrow's work about the FTC, fundamental theorem of calculus, in that proof of matter. So where does the plagiarism really come into hand here? We see Leibniz do his own work. Yeah, he exchanged letters with Newton, but where did it really come in? It was a man of the name of Nicholas Fatio. He suggested that Leibniz borrowed from Newton. And essentially what happened from this was Leibniz kind of didn't really panic. He kind of wrote letters to the Royal Society, and he said, look, this is my work, all our stuff. And essentially what happened was Newton, at the time, could not publicize his own work. And by the way, and the reason why was because he was in a feud with Robert Hooke. And Robert Hooke was giving him some scientific struggles with optics and gravities, which pretty much Robert Hooke accused him of stealing his ideas. So here we have Leibniz being accused of stealing Newton's mathematical calculus ideas, whereas Hooke was saying, look, you stole my optics and gravity scientific work. So it's really a whole fiasco here. It's like dogs and cats raining from the sky. And essentially what happened was, and this is my understanding of it, I think Leibniz, he did do a lot of things on his own, but there existed things that he did take from Newton. And I feel like if Leibniz would have just credited Newton in his work and give him credit, that's all you need to do. Like, that's why we cite sources. That's why, if I write a paper, like, let's say right now I write a paper on Newton and Leibniz, if I don't credit James University's video, if I don't credit, my reading from Hodgkin, that's plagiarism. It's essentially saying, look, this is my ideas. Or, these are my ideas. It's not. I'm getting these ideas from my readings, from my videos. If Leibniz would have just gave credit to Newton, but still did some of his ideas, we wouldn't have this problem today. And that's the big problem, I think. That is the overarching thing that I got from this module part, is essentially, like, Leibniz had a lot of good things going for him, but Newton was the true genius. He was the one that really saw some of these things. And in 1669, he published that, Fluxions. And after that, he wrote some letters with Leibniz, all that other stuff. But you really see, and also the most ironic part about this too is Newton, in his publication in 1687, which was pretty much after Leibniz did some things, he actually referred to Leibniz. So Newton referred to Leibniz, but I feel like Leibniz never referred to Newton in his work. So Leibniz got off the hook. When Nicholas Fatio accused him of borrowing from Newton, he kind of let it go, right? The Royal Society said, we'll let it go, whatever, it's okay. But then what happened was, if I can see my notes here, the man of John Keel, who wrote a book on centripetal forces in 1710, he accused Leibniz of plagiarism again. And this would then lead the Royal Committee, okay, or the Royal Society, I'm sorry, I can't even get my crap together right now. The Royal Society, they formed a committee which was biased. And because why? Because Newton was the head of the Royal Society. So essentially, Leibniz got screwed over. And he pretty much was found of plagiarism. And nothing really, like, he wasn't arrested or anything bad, nothing bad came from it. It's just it's pride. It's pride. It's, I published it, I did it. It's pride. And essentially, Leibniz, his career ended on a bad note. It ended on a bad note such that I feel like Newton got more credit than really, I'm not even going to say than he deserved. Because Newton did deserve a lot of credit. But I will say, Leibniz definitely got a little bit dissed. And I really just feel like, to be honest, it was a little bit corrupt in the Royal Society. Leibniz got screwed over. The committee voted against him because why? Because Newton was on that Royal Society. So there wasn't a whole lot Leibniz can do. But again, in general, people objected to their findings because of plagiarism, and it was a big thing back then. So I really honestly feel like, to conclude my thoughts here, I think that both of them did a lot of work in the contribution to calculus, including other people like Vieta, Descartes, Cavallari, Barrow, Fermat, and it's a team effort. I just wish Leibniz would have credited Newton in the letters and other stuff, and we probably wouldn't have this issue today. Give me your thoughts on this matter, on the calculus and the reasonings and the objections, and we'll go from there. Adios. Have a great day.